would like to call Aditya Mehra, Neetu, Maria Koshi, Sridevi, Shamlini, and Vaibhav Kohli.
Hello everyone. So I'm Vaibhav Kohli. I'll be walking you through the presentation about Kubernetes, giving you some hints about that. That's Shamlini, and we have Neetu and Aditya and Sridevi over there. So how many of you actually have worked on Dockers before? Can you raise your hands? Okay. Kubernetes, anyone planning to use it in production or something like evolving? Okay, that's good. And I can see very few laptops over here. Can you raise your hands who actually want to do the workshop very badly and have brought their laptops with them? Okay. So please contact any one of us over here. They'll be with the pen drives. If you don't have the setups, we'll be providing you the setups. So kind of we have packaged Kubernetes in one VM, and we'll be providing that to you so that the installation time is not wasted, and you can go back and try out all the commands with that. So you can, by the time I'll start with the presentation, we'll go ahead with that and we'll cover most of the things. Okay. For my introduction, I lead the Kubernetes Bangalore meetup group. It's been more than a year or so, and we have been conducting sessions in Red Hat and as well as in VMware India site, JP Nagar. So if you are interested, you can just go to meetup group and just sign up the Kubernetes Bangalore meetup group. We are gonna have some meetups coming up soon. Question comes in your mind, what is Kubernetes? Why are we discussing it more? And why we had Dockers before? Why is this new concept coming up, Kubernetes? And what are the key concepts I'll be talking about? Architecture of Kubernetes, as well as some of the real-time use cases where Kubernetes can be evolved and can be used in production systems. Then we'll do a small demo, which Shamlini will walk you through, and then we'll give you the handout printouts. You can try out that command. And if in case we have a restricted time of 1.5 hours, if we are not able to complete, you can go back home, try out that VM and the commands as well. And even we'll upload it on Google Drive, so those of you who doesn't have the laptop, they can just go back home and try out all that commands. So Docker, as I asked before, for the newbies who are like hearing this term for the first time, Docker was actually launched in 2014 around, even before than that, but it gained a lot of success in 2014. It's actually using the concepts of LXCs. So LXCs was a Linux containers, which was way back in 1980s being used. It just does one thing. It allows a particular process in your system to give some of the resources, and it will feel like it is running in a virtualized environment, but it's actually not doing any virtualization magic. It is just using the concepts of LXCs. And Docker is built on top of it. So you can actually, on one host, you're running, now Docker support is coming to Windows 10 server also. If you're running Windows 10 on this laptop, you can have multiple containers on top of it. And these containers will actually be kind of using will be having the user libraries. Rest everything it will be using from below the host layer. That's why it's very lightweight. So on top of Linux, you can have Ubuntu, you can have Fedora container running, but they actually are just Docker processes which run and which gets that memories and resources. Now the issue which comes with them is that they are very lightweight. You can easily deploy them, but the issue is that they are not persistent. And if your host layer fails, your entire Docker ecosystem fails down at that point of time. You will not be able to run the Docker containers, or you'll have to write your own mechanism to do that. That's where we came in with Kubernetes. That Google launched it in 2014 I/O, and it was a very big hit. And currently in the market, it's much powerful than Docker Swarm, which is also one of the orchestrating tools, which I won't be covering, but yeah, if you have any questions, you can ask me post the session. I believe that Kubernetes is evolving as an enterprise product because Google is using containers from last 15 years in their technology. Every time you open the Google search page, you type one search, one container gets fired up. That's how they are using containers. So Kubernetes actually provides you self-healing. They provide you auto restarting. They allow you to schedule across multiple hosts, and also does the replication for you for the containers. These are some of the benefits of Kubernetes. And at minimum, Kubernetes can schedule and run containers as well as manage containers on top of your virtualization stack. So you will be having VMs. On top of them, you can have multiple containers deployed and do the management and everything for them. That's where Kubernetes comes into the picture. Kubernetes comes from the word that is governor. So that's what its job is, governing all the containers in your ecosystem, doing the replication for them, as well as doing the scalability and load balancing and other stuff. Its schedule runs and manages containers on virtual machines, as I said before. And it is 100% open source and written in Golang. That is the Google's language. And it's quite easy. If you go through the Kubernetes GitHub repo, you can easily learn it in a day or so. Yeah, some of the concepts like threading and all, they treat it in a different way, which will require some time to dig through the code. So that's the architecture of Kubernetes. As you can see before, I have an ocean of containers. I don't know what to do with them, which node to put them on, how to schedule them, how if one of the container fails up, how will I bring the other container up. And below, if you see the picture, there's a Kubernetes master setting, and he's doing all the job. So Kubernetes works in the architecture of having a master and then having multiple nodes. And in the workshop, the VM which we are giving to you, it has master as well as node in that same VM itself. So we are treating that VM as node as well as master. Otherwise, in production systems, you should have master deployed separately and nodes deployed separately, because that will create a good bifurcation for you to manage your master in a very well way. That's the high-level architecture. So there's a master, etcd. You must have heard of it. It's a key value store, and Kubernetes uses it to manage all its pod starts, what is the IP addresses and other stuff. It sits in the master. We have the API server to actually interact with your Kubernetes cluster to get the number of pods running and containers running. Scheduler, which will actually sits in the master and schedules the pods onto the nodes. So it actually keeps the resource track of every VM. And as you see over here, the minion is written. Minion is actually the older term which was used. Now it's nodes, as I've mentioned over there. Nodes are kind of VM, or they can be the physical machines. And as you see, they have pod. Pod is like group of containers. You can have two containers, like you have Tomcat container and you have a UI container. Now both of them you want actually to be tied up to be together, but they are independent. So you can make two separate containers and tie them up in one pod. That's how Kubernetes works. Kubernetes treats your containers in a group and called it as a pod. So scheduler schedules it as per the resources you have and schedules them on every VM or the node, which you can see over here. And kubeproxy actually handles the networking of the services and other stuff. So that's the high-level architecture of Kubernetes. This some of the terms which I've written. So you have a master node, which will actually control your cluster, which will be talking to your nodes. And you have a pod, which is like group of containers. You have services. So if you deploy a service, say Tomcat, and you want to expose it to the user, you won't actually expose the IP address of the pod. You will make it as a service and then expose it. It's kind of a load balancer in between. That's where Kubernetes provides you services. You can have labels to identify your pods, like development pods, production pods. You have containers, which every one of you must be knowing. It's the one which is the Docker containers. Even Kubernetes has the support for Rocket containers. Node contains kubelet, which is the process running in node informing that this is your master, this is the command which is coming to you. You have to take care of that command. Kubernetes proxy, which I explained, takes care of the networking. And Kubernetes control plane, which we talked about before, is handling the API server, the controller manager, and the etcd key store. That's the high-level architecture of Kubernetes. Kubernetes deployment can be done on virtualization stack as well as can be done on the direct hardware physical machines. But it is mostly used for virtualization stack because you have more control. You can deploy more number of nodes as and when required. For physical machines, you have to get one and plug it in. So it supports Vagrant, VMware on top of Windows Azure, GCE, AWS, all the top leading cloud providers. So that's the Kubernetes ecosystem, very well spread across all the OSs. Replication controller is one of the concepts which is very vital in your application. Suppose you have one pod deployed, and if it goes down, what will you do? You don't have a backup, you have to spin up a new backup, and you have to make a new pod up and running and then work with them. But this issue resolves it very well. There's a replication controller service in Kubernetes. It will make one backup pod for you and keep it always running in the same node, or it can be in the different node. And as soon as the other one dies, it will make all the system calls routed to this one. That's how we have showed that if worker 1 fails, worker 2 will take the load for you. And immediately it will know that worker 1 has failed, so I should schedule one more pod because RC was defined as 2. I should have 2 pods running. So that one pod which failed in worker 1 will go to worker 3. That's the advantage of replication controller. Always you can define that I should have RC as 2, so there will be 2 pods always running in the system. If one fails, the other will take the load, and the new one will also get deployed parallelly, which we'll see in the hands-on lab exercise. Then, as I talked about service concept, so you might be having multiple pods at the backend. Now, multiple pods means multiple IP addresses. How will you map them? So Kubernetes allows you to make a service which will talk to all the backend pods, and he will keep the map that I have to route the service to this pod, or I have to pod the to 937 to the different port or to a different IP address. It acts like a, you can say, reverse proxy for you, handling all the server's requests in the backend, and then your client can actually talk directly to the service. He doesn't need to talk to the pod. That's one level of abstraction. And if you see the services, this is something which you might have heard a lot, microservices concept, which is coming up. And it also helps up in code pipelining and other stuff. So that's the service concept. And with services, you can also add a load balancer. Like if you're doing this cluster management in AWS, you can have a load balancer in front, and which will talk to your service and then back into your pods. That's the entire overview of services. So that's around Kubernetes, a little bit of overview. So you got to know like how actually we are going to have the nodes and masters. But in the current experiment, the VMs which we are providing to you have master and node in the same. But you can have them bifurcated. It's just due to the time constraint, we have packaged them as one, so it will be easier for deployment. For the installation, you should have one Fedora OVF, which can be provided to you, and you will be needing VirtualBox to run that. So you can raise your hands if someone is still not having the access to the VirtualBox or VM. Okay. So we'll be doing a simple experiment around. We'll be deploying a pod with one container. We'll be deploying pod with 2 containers inside them. We'll be doing a replication controller example that we'll make a replicas, and we'll see if we kill one replicas, what will happen to the other one, how it will take the load. We will do rescheduling of the pods on different nodes. We'll do scaling of the pods. We'll do Kubernetes service, and in the end, we'll deploy one J2E application, which will be like much more closer to you. You can deploy a Wildfly and a system memory database, and you can actually, you'll see a Movieplex system deployed, and that will be running inside a container. So that's our goal today, to complete these exercises, and let's hope we are able to complete most of them. And those of you who are not with laptops, I would say that leverage the session. You can sit with someone who's with a laptop and can share the laptop as well as do parallelly with them. That will actually help you to even see the concepts, how it is coming up, and then you can go back and try it out. I'll hand over to Shamilni. She will walk you through some of the hands-on lab commands, how we are going to do them, and then we can start with the workshop, which is our main motto. Over to Shamilni.
Thanks, Vaibhav. Just to give an overview about the Kubernetes installation, right? So what we have done, we have prepackaged the installation of Kubernetes inside the VM. So you have the VM which has Kubernetes already installed. To know about how we have done the installation, there is one video which is already there in your pen drive copy folder, which you can go through and you can try out in your site. Why we did the installation prepackaged? Because we didn't want to spend time on installation instead of trying out the commands. If you have copied all the content from pen drive, you must have the software for Fedora VM, VirtualBox for Windows or Mac laptops who has. You should have the PuTTY to do SSH for the VM to try out commands. And documents covers your Kubernetes installation steps.
Same VM which all of you have, Fedora Kubernetes demo. If some of you face some of the issues while executing some of the commands, please do raise your hand. Volunteers will come up and help you across with that. So you'll get the VM imported properly, you'll be able to log into the VM. The password is workshop, and so you can switch inside the VM and execute all the commands inside VM. You won't be facing much of the issues. But if you want to try that commands outside, you can actually go to the terminal. That is, I'm showing it over here, activities. Because in some of the boxes, VirtualBox doesn't work well in some of the Windows system. So type terminal over here and ifconfig, that is to get the network configuration. And you can get the IP address and then do a SSH from outside, or you can actually use PuTTY to do that. So you'll be getting an IP address over here, or I would suggest you can run the commands from inside the VM also. You won't be having much of the issues. So the VM which we have provided to you will act as Kubernetes master as well as minion. And we could have done it on workstation as well, but we thought VirtualBox will be better. So that's why, because workstation comes with an enterprise license. So you can try them out over here, and once you get it, you can do a SSH from the terminal, or you can execute the commands inside the VM. I'll be doing it inside the VM. Write control of your laptop, and you can actually come out of the VM. But if you face some issues, then actually I will say execute the command inside the VM. At least you'll get the feel that how they are working. So how many of you are still struggling with the setup or facing some issues? Okay. Anyone else? Okay. So I'll start slowly with the commands, and you can actually have a look over here. First I'll execute one of the commands, and then you can try out the same commands in your laptop. So once you get the VM, you can become the root user using sudo -s. So you can do sudo -s in order to become the root, and the password will be asked, and you have to enter workshop. I am actually the root user now, and just do cd. So this is a very simple setup to become the root user of your Fedora machine, which we have provided to you. Sudo -s, and then just enter the password as workshop, and you'll become the root user. Just do cd and come to the home directory. Home is this one. Now once you do ls over here, you'll be able to see one of the folders, which is Kubernetes Java sample. So Kubernetes Java sample is the folder which is like, it is also on the GitHub. We have provided you the link in one of the Google Drives, and it contains all the data and everything. You can go back home and try that link as well, and that I'll maintain that repo. It is actually my repo, and you can go down and pull the code even later as well. So you do sudo Kubernetes Java sample and do ls. So over here you will get everything packaged which we are going to do through this hands-on lab exercise. And you have to do a very simple setup. You have to start Kubernetes, which is like just executing this shell script, start Kubernetes sh. Let me clear the screen and then show to you. I do ls, and there is start kubernetes.sh. You have to run this script, that's it. Executing that start kubernetes.sh, and you shouldn't be facing any issues. Yeah, that's the command, but you shouldn't be getting any errors or something that this service failed to start, or this port is not available, and some other kind of stuff. Yeah. So start Kubernetes is actually, if you open that file, it generates a RSA key and it starts all your Kubernetes services. If you see over there, whatever I explained in the presentation, like etcd, your API server, your controller manager, your Docker, everything you will be running through that command. So if you open that script, it's just an automated script I've written. You can also go and start the services manually. Say service, Kubernetes, app manager or controller manager, start, restart, and other stuff. If you have any questions, I can take that, or even we can discuss like how Kubernetes can be deployed in production environments. So that's one of the major things which comes to me, that how will you deploy the Kubernetes in production environment. And let me show you one slide on that. You will actually require a persistent storage. Now, what is the requirement for that? Because your pods are actually very lightweight. They are not having some memory, or you can say some volume attached to them. So you can have volumes predefined, and we will see some of the YAML files which we are going to write to make a pod. You can attach that volume, and that will be the persistent storage. So if one of your pod went down, like we saw in RC, the other one comes up, he just get attached to that persistent storage. So you won't lose the data. You can have the volume sitting alone and your pods running separately. So Kubernetes in production will actually have persistent storage required. Then there's something called as secret information. Now, I might be having an application where I have, say, username and password. Now, do I store them directly onto the container? I can't do that. Someone gets into the host, gets into the container, he gets the username and password. So Kubernetes allows you to declare secret service, which is upcoming service. You can have that service declared, and you can have username and password defined in that. That will be encrypted and stored. Now, whenever you declare a new pod, you just attach that service to it. So that pod will only have access to that service. This is one of the more important feature which Kubernetes provides to you. Now, you should have a private image registry. Everyone knows Docker images. Docker images are something which are available on Docker Hub. You can download them like Ubuntu image, and you make a Ubuntu container out of it, Docker container running. But the problem is that public images might be corrupted, or they might have been issues, or while downloading there might be a hack or something in between, and you get a wrong image. So it's always advised to have a private image registry for your company, which is accessible only inside the company, and you can download the images from it. That's one of the Kubernetes in production. You should do the resource management very carefully. You should assign that which pod should be given how much CPU, how much memory, and how much of the, say, network ports should be open for that. And if actually your program, you don't know that how much CPU utilization that program is doing, you are not writing a good code. You should always be knowing that how much this application will be knowing of the, you should be knowing the figures, that approximately how much CPU utilization my code will consume, and deploy the pods as per that. Set a two-step load balancer, which I explained before. You have service as the load balancer. Before that, you will be having a AWS load balancer or something, which will provide you the complete hierarchy. Then there is something like blue-green deployments. Always manage a replication. Use in code pipelining, that is the entire flow. DevOps must be the term which you must have heard, and microservices comes over there. So Kubernetes can be used in DevOps very well. Do a good logging and monitoring of your Kubernetes cluster. Logging can be done with help of Kafka, and monitoring can be done with help of Heapster, or there's something called as InfluxDB, which do real-time analytics for you. So you should be having all these mechanisms in place if you're going for Kubernetes in production. And trust me, it works. It's one of the best solution available to manage your container infrastructure, better than Docker Swarm. We have done that in VMware. Even some of our products are actually going to be deployed in Kubernetes going forward. Coming back to the hands-on lab, which is our main motto. Let me just switch back. So I believe everyone must have tried the services by now. You must have started the cluster. We'll go ahead with some of the commands. As you can see, there's a pod with one container. So if you see pod with one container, there is actually wildfly.pod.yml. You can have a look over here. I am actually walking you through what is a YML file, and then you can go ahead with the commands and execute them. So over here, I declare the API version of my Kubernetes, version 1. I declare it's a kind of a pod. I declare what's the name of my pod. Oh, label. So label is something like key value. I can give over here dev and say production or something like that side of thing. It's your label. Then I'm declaring a spec. Spec is where you will define that which container will be packaged inside this pod. So I'm actually pulling JBoss Wildfly container. This container is actually pulled from the Docker Hub, but all of you don't have internet connection, but you will still see the magic. You will get the pod running because the VM is being packaged with the image itself. So if you do Docker images, you will be able to see that image over there. And that's what the second thing says, that image pull policy. If not present locally, then go ahead and pull it from the Docker Hub. But you will be having that images, and we are declaring that on which port my Wildfly should run. That's the port defined over here. So this is a very simple YAML file. You can even write a JSON file to declare how your pod should run. You can configure that. By default, it is configured to the public Docker Hub, but if you have your own private registry, you can go into the Kubernetes config and declare that as private registry pointing. It's available on the GitHub page, how to point your Kubernetes cluster to a private repo.